we need to talk about this. Okay? So, first, while I got it over here on the board, I want to talk about what Joe just did. So this is number 6. This is the end behavior question. So remember, when we do end behavior, it's the limit of the function as x approaches negative infinity, and the limit of the function as x approaches positive infinity. Now, this was a no calculator problem. You are not to graph this on your calculator. You are to know when you look at a problem that has a degree of x to the 5th odd, that we start down and end up, right? We don't really care about what's happening in the middle. We're concerned with the ends. So Joe has this graph. As it starts on the left side, we're going down. On the right side, we're going up. Anybody have a question about that? This is the way we write it. We write it exactly the way he wrote it. He did a good job. Okay. Now we need to talk about this. This is kind of a disaster. And I know, I'm not even going to name who put it up here, but that person wasn't alone. That person was taking advice from others, and a whole bunch of people are off base. We need to talk about this. What is cosine 2x? You can't do a problem with a 2x and an x. It's not possible. You have to make a match. So what do we know about cosine 2x? Whoa, 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 I told you to use your notes. This is inexcusable. What do we know about cosine 2x?
Cosine squared x minus 1.
It's what?
It's equal to cosine squared x minus 1.
No, not cosine 2x. Cosine 2x is 2 cosine squared minus 1. So this is 2 cosine squared minus 1. Now, it's other things also. It's 1 minus 2 sine squared. It's cosine squared minus sine squared. But because the problem has a cosine in it, I'm choosing this version. Does that make sense to you? It wouldn't be as smart to do 1 minus 2 sine squared, because then you've got sines and cosines. So I'll use that one. So I've got 2 cosine squared minus cosine minus 1 greater than 0. This is 2 cosine squared minus 1. I'm going to subtract the cosine over because I got to have a 0. Now, what am I going to do with this? Factor it. That factors 2 cosine, cosine, minus here or plus here. So my kind of key values are cosine is negative 1/2 and cosine is 1. Mrs. Mills, happy pie
Happy
day.
spring break. Happy pie
Do
day.
you want a treat? We got donuts.
No, I gave up chocolate. Yeah.
What we got?
We have so much more than
Apple pie. Okay. All right.
Happy
Well,
spring
thank
break.
you. Same to you,
And you don't
Mrs.
have to make me anything. You eat it. Okay.
Okay. All right, so everybody good to hear? All right, so where does the cosine equal negative 1/2? We have to figure that out. The cosine is negative 1/2 here and here. And if cosine is 1/2, the angle is pi over 3. So that would be 2 pi over 3 and 4 pi over 3. Where is the cosine 1? Here, right, 0. Okay, now I love the graph. I'm going to go ahead and use this graph. I think it's perfect. But I'm going to get rid of some of that stuff. So, we don't need this in there anymore. I'm not sure what even that was, but we don't need it. So, all right, so here we go. The points we're concerned about are 2 pi over 3 and 4 pi over 3. This is where we actually equal these two things, right? Here's negative 1/2 coming And then here is the other point, right? I'll go ahead and put that one in even though we're not counting it on. All right, now, guys, these are multiplied and they're making a positive. So what does that mean? If they're multiplied and they make a positive, then what? They either are both positive, right now stop, let's look at our graph. That means we're above these two dots and we're above these two dots. Now these dots are open because this is a not or equal to, right? So, where am I above the top dots and above the bottom dots? Nowhere. Nowhere. Those dots are not colored in. This is not an or equal to. So there is no answer to the positive situation. Well, what if they're both negative? Well, then I have to be below the top dots and below the bottom dots. If you're doing this on the unit circle, you would want to be left of these dots and left of that dot. X less than, right? So I'm looking at my curve here. I need to be below both sets of dots. So aren't I right here? So the answer to the problem is 2 pi over 3, 4 pi over 3. Not a hard problem. We have to make sure we can do that kind of a problem. Actually, pretty easy. Bingo! Okay, all right, now, I gotta erase this one. We're over there on the sideboard, and Daniel, you got it right. I can't remember what angles you used. Can you tell me real quick, just so I have it on the video? What did you use?
7 pi over 4 and pi over 6.
So he wrote that as the sum of 7 pi over 4 and pi over 12. Guys, there are lots of ways you can get 23 12s. He did it with
Pi over 6.
pi over 6. Yeah. He did it with 7 pi over 4 and pi over 6. If he adds these two together, gets a common denominator, this is 21 12s, 2 12s, 23 12s. So then he used his formula, cosine, minus sine, it's all over there, and he got the right answer, which is, for the sake of video, already up here. That's the right answer. Cosine, minus sine, if we're doing it with his numbers. Okay? All right. Number 4 was done over there correctly. Number 4, it's simply a composition. It is done very well. I think it's perfect. You have to find G of 3 first. So G of 3 is negative 2. Look at your table. And then we plug negative 2 into F. Guys, we're not supposed to be talking about anything but this. So that's 3 to the negative second and negative 2 squared. So 1/9 plus 4, 37/9. Beautifully done over there. Good job. Nobody did 5? I know, this is not hard. Okay, so what happens? First thing you do is combine those. How do you combine them? You combine them as a division. So it's ln x cubed over x. So it's ln x squared equals 4, right? Then we log roll it. What's the base on ln? E. So e to the 4th equals x squared. We want x. So we will square root both sides, plus or minus e squared. But, whoa, stop. In the original problem, can you put a negative number right here? No. So therefore, the only answer to the problem is e squared. 6 we already did. Number 7 is current material. I can't believe nobody put it up here. We need 2 times the angle whose tangent is negative root 3. All right, stop right there. What is the angle whose tangent is negative root 3? That notation right there means I can only look over here. If it's negative, it's down here. If the tangent, y over x, is root 3, doesn't this point have to be 1/2 root 3 over 2? To get y over x to be root 3, and what angle is that? Watch it, watch it, I heard somebody say it right, negative pi over 3. Guys, one more time. This notation means you are limited from here to here, period. When you say 5 pi over 3, you are starting here, and you are traveling all the way around to here, right? Can't do it, because in this world, this is all you got. So you gotta get to that point without going over here, and the only way to do it is to go down. So, 2 times negative pi over 3, which is negative 2 pi over 3. All right, now what's the rest of the problem? Minus 1/4 times the angle whose sine is 1/2. Right? Okay, what? Sine 1/2, what is that? You should know that one. Pi over 6. So that's 1/4 of that would be minus pi over 24. Get a common denominator. Looks like my answer is negative 17 pi over 24. Okay. Now I'm going to make you either super happy or super bummed. Mega review sheet. Mega. While you are on spring break, or the night you come back from school, I don't care. I hope you'll do 3 problems a day while you're on break to keep your mind fresh. This little quiz was a bit that we did together was a little bit of a wake-up call that you have forgotten a bunch of stuff. Some of it new. While you are gone on spring break, try to do problems every day. It won't take long. When you get up in the morning, sit down, do a couple problems. Keep your mind fresh. There's a bunch of them, 29 to be exact. Some of them are real quick, and some of them are going to take a little more time. Some of them do require a calculator, but not very many of them, and they are marked. Okay? This is due when you come back. I got it all squeezed in on the paper, but it was hard, so you might want to do it on a piece of paper. I will post my solutions in school with you when I get a chance to do that. I've worked them all out. Okay? All right, everybody's, oh wait, stop, we gotta go to mass. We're going to mass.